In this video, we're going to take a look at what's going on with the call stack whenever we do recursive function calls. So in one of our previous videos, we wrote this factorial function here, and we wrote it in a recursive manner. So you can see on this line of code here where we're calling the function in which we're defining. So this here is considered to be a recursive call. And I think it's beneficial to know what's going on behind the scenes or what's going on in memory to sort of demystify what's going on with recursion. Because a lot of times when people first start doing recursion, it seems like some magical act that's occurring, and it's really not if you understand what's going on behind the scenes. So just sort of as a quick review, anytime that we call or invoke, whatever word you want to use, anytime you invoke a function, you're getting a new area of memory that's being set aside for that particular function and all of its local variables. So every time that we call that factorial function, we're getting an area of memory set aside. We call that a stack frame, or an activation record is what some people call it. So let's take a look at what's going on with the call stack and look at the actual stack frames whenever we execute this program here. So whenever we execute a C++ program, we always start execution in main. So we'd have a stack frame that would be created. So let me draw the stack frame here for main. So this is going to be main stack frame. And the local variable num, we'd have space allocated for it. So we'd have num here. And say that the user, I don't know, we ask the user to input some particular number here for num, and we'll say that they input the value of 4. So we'll say the value of 4 has been inputted here for num. And what happens is that we call this factorial function. So we'll call fact, and we call fact, and we pass the value of 4. So what happens is as soon as we call this fact function is we get a new stack frame here pushed onto our call stack. So we have a new stack frame here, and this is going to be for whenever we call factorial with the value of 4. So the value of 4 gets copied up here to our formal parameter n. So we'd have n here having its own copy of the value of 4. And as we go and start executing this factorial function, we can see that 4 is in fact not equal to 0. So we're not in our base case, so we're in our recursive case. So what we want to do is return n times fact of n minus 1. So that's going to just be, for this particular case, it's going to be 4 times the factorial of 3, since n minus 1 would be 4 minus 1, so that's 3. So we cannot actually issue this return statement here. We would be returning it here to main, where it was invoked, but we cannot issue that return until what? Well, until we actually get to this base case and start unwinding. So let's go ahead and continue our story. We got to execute this factorial function again. So we get another stack frame that's pushed onto our call stack, and draw a stack frame here. And this is going to be for whenever factorial, or whenever our factorial is called with the value of 3. So this time around, we'll have the value of 3 being passed in. So we can see that 3 is not 0, so we're still not in our base case. We're going to do the recursive case again. We're going to try to do a return, but we still cannot do a return because we just simply have 3 times, and we have another recursive call here where we have factorial of 2. So we get another stack frame being pushed onto our call stack. This time it's for fact of 2. So we call fact of 2. And then we'd have n would be equal to 2. So 2 is not 0. So we're not in our base case. And we want to return 2 times. So 2 times the fact of 1 this time. So we'd have another stack frame being allocated on our call stack here. And that's a really skinny stack frame. Let me draw it a little bit bigger. So we got another stack frame that's being allocated here on our call stack. And this is for fact of 1. And this is whenever n is equal to 1. So n is still not in our n's still not our base case. So 1's not equal to 0. So we're still in a recursive case. So this time we'll have 1 times the fact of 0. So this time we have another stack frame being pushed on here. And this is for fact of 0. So we have fact of 0 being called. And now n is equal to 0, and 0 is in fact our base case. So now we can return the value of 1. So we were going to return the value of 1. Where does it get returned to? It gets returned to the point of invocation. So this part here ends up being 1. And let me go ahead and pop this stack frame off. So as soon as we finish execution there, we can hit that return statement, and that gets popped off. And so now we'd have 1 times 1. And where does that get returned to? Well, it gets returned to the point of invocation, which was called from here. So we'd have the value of 1 being returned there. And so then we'd pop off this from our stack frame. We pop that, or pop off the topmost stack frame, since we've now completed that. And so now we can return 2 times 1. Where do we return it to? We return it to the point of invocation, so we'd have 2 being returned here. And we would pop off that topmost stack frame as soon as we issue that return statement. And then we'd have 3 times 2. Where does it get returned to? Well, you know the story by now. It gets returned to the point of invocation, so we'd have the value of 6 being returned here. And so let me go ahead and delete this stack frame. And so we have this is our picture now in terms of our call stack. And then we'd have 4 times 6. Where does that get returned to? It gets returned to the point of invocation. So we'd be returning the value of 24. So let me go ahead and make that happen. So we'd be returning the value of 24 here back to main. So main's going to have the value of the result of doing that factorial function and doing it recursively. So that's basically what's going on there in memory. And so you can see here in main that we would just output that value of 24. So we do a cout, and now that we've returned the value of 24 here from doing that original function call of fact of 4, we would just output that value. Once we output that value, we don't have anything left there to execute in main, so we could have this last stack frame being popped off of our call stack, and that would be the end of that particular program. So hopefully this video has provided you with some insight of what's going on behind the scenes whenever we do these recursive function calls, and demystified some of that activity. If you can draw what's going on in memory, it definitely helps you out and makes you a better programmer. So that's it for this video.